Welcome back. My name is Dr. Alfred Msekiwa. I'm a senior lecturer in biostatistics at the School of Health Systems and Public Health at the University of Pretoria. In this week, we are dealing with Introduction to Statistics, and in this session, we are talking about different types of data. We cannot talk about statistics without talking about data. Data is the blood of statistics. It gives life to statistics. We will talk about quantitative, also called numerical data, as well as qualitative, also called categorical data. We will also talk about 4 scales of measurement, moving from nominal to ordinal to interval to ratio scale. It is important to know the different types of data because the type of statistical analysis depends on the type of data. In other words, if you don't know the type of data you have, then you don't know what statistics can be performed on your data. Data can either be quantitative or qualitative. Quantitative, also called numerical data, consists of numbers and is usually a result of either measuring something like weight in kilograms, height in centimeters, or it could be a result of counting. For example, the number of children in a family, which can be 0, 1, 2, and so on. Qualitative or categorical data is simply observed. For example, what is your blood group? It could be A, it could be B, AB, or O. It is qualitative data and can be put in categories. And it is not numerical because there are no numbers there. Now, let's get a little bit deeper. We said quantitative data is a result of either counting or a measurement. Count data are also called discrete data because they can only take specific distinctive values, e.g. 0, 1, 2, 3, and so on. It cannot be 2.5, for instance. You can't have 2.5 children in a family. We distinguish that with measurement data, which is continuous, which can take any value within an interval, e.g. weight for a sample of people can be any value, let's say between 40 to 100 kgs. The number of decimals are only limited by the measurement instruments. So you can have 40,1 or you can have 40,15 depending on the instrument the accuracy of the instrument that you have. We need to define a variable as we are going to use it a lot in statistics. Now, a variable is a characteristic that can take different values for different individuals. E.g., my age can be 21 years and your age can be 40 years, for instance. The variable in this case is age. The values 21 and 40 years, they are data. See the picture in the slide to understand the relationship between data and variable. From the picture in this slide, we remind you that variables can either be qualitative or quantitative, which can further be divided into discrete or continuous. The same classification for data applies to variables as well. Now we have understood the different types of data, let's move on to different scales of measurement. There are 4 types of measurement scales, which are nominal, ordinal, interval, and ratio scales, in that order. Some examples are given in the slide. Nominal is just categorical with no order, e.g. gender to say male or female. Ordinal is categorical but with some order, but unequal intervals between the orders. For instance, pain from mild, moderate to severe. Interval scale is now numerical data with equal intervals between values, but no absolute zero. and 0 point, and we cannot apply multiplication and division to it. For example, temperature in degrees Celsius. The highest scale of measurement is the ratio scale, where we have a measurement, equal intervals between numbers, absolute zero meaning absence of variable, and we can apply multiplication and division. For example, weight in kilograms. Now we will get into each of these measurement scales in more detail. We start with nominal scale of measurement, just categories with no basis of ordering or ranking. No category is better than the other. Examples are province, gender, marital status, just to name a few. When doing a questionnaire and you are asking these nominal questions, make sure your categories are mutually exclusive, which means there is no overlapping between the categories. And also make sure that they are collectively exhaustive, meaning that all categories that are possible are included. Now you can think and maybe give your own examples of nominal variables. Nominal variables with only two categories are called binary variables or dichotomous variables. These are very common in epidemiology. We usually write them as yes or no variables. For example, do you have the disease? Yes or no. Are you female? Yes or no, and so on. In analysis, we usually code them as 1 for yes and 0 for no. Now, let's talk about the next scale of measurement called ordinal. As the name suggests, there is order or rank. However, the ranks are not evenly spread. Examples of ordinal scale variables include: what is your highest level of education? Is it none, primary, secondary, or tertiary? The difference between none and primary is not the same as between secondary and tertiary education. For instance, see a second example in the slide. We have covered nominal and ordinal scales of measurement. These two apply to qualitative or categorical data. Now we move to quantitative or numerical data. We start with interval scale of measurement. The example is temperature in degrees Celsius. It is a numerical value. The distance between units is equal. In other words, we say it's equally spaced, but it has no absolute or true 0 point. In other words, temperature of 0 degrees Celsius doesn't necessarily mean absence of temperature. Now we have reached the highest scale of measurement called the ratio scale. It is called ratio because it allows for ratio comparisons, which we could not do with temperature in the interval scale. See more explanations in the slide. Examples of a ratio scale of measurement is weight. It is equal intervals, ratio comparison, and true 0 point. Ratio comparison means if you weigh 100 kg and I weigh 50 kg, then you weigh twice as much. Whereas, if we were comparing interval scale, we cannot say a place with temperature of 40 degrees Celsius is twice as hot as a place with a temperature of 20 degrees Celsius. Probably some of you didn't know this. It's just a sliding increasing scale, but we cannot apply ratio comparisons to temperature as we do with the ratio scale of weight. This table summarizes the 4 scales of measurement, showing that it becomes stronger as one moves from nominal to ordinal to interval and ultimately to ratio scale. Read this slide carefully to see the differences between these scales of measurement. Now that we have come to the end of this session, if given a variable and its units, you should be able to tell whether it's quantitative or qualitative, and also whether the measurement scale is nominal, ordinal, interval, or ratio. If quantitative, you should be able to tell whether it's discrete or continuous. Here's my email address for any questions. Thank you.